This example is for MGF 1106 Liberal Arts Math from section 2.4. When you're given two set statements, such as these, we have two set statements which have operations in them, and we want to determine the equality of the set statements. Now, two set statements are considered to be equal when they are equal for every set, in this case P and Q, that you can create. So we're going to use a deductive process to determine whether the two set statements are equal. And this is how you should show your work when you're doing your homework, taking a quiz, and taking the test. What we do is we make a chart for each set statement. And you notice we do not have any elements in our set, P and Q, but we have regions that comprise or that make up the set. So what we do is we create a table for each set statement. So let's start with set statement number, we'll call that one 1, and we'll call this one 2. And in one column, we put the set. In the other column, we'll call it the corresponding regions. Remember, if there's two subsets, whether they're called A and B or P and Q, there are 4 regions in the Venn diagram. So let's do this in pieces. You notice we have a union, but before we take the union of those two sets, let's figure out what regions make up each one. So for set P is made up of regions, all the elements in regions 1 and 2. So remember, these are region numbers, and they represent elements that would be in those regions. Now we have to unite that with the complement of Q. So you could write down Q, and Q is made up of the elements in regions 2 and 3. And then Q complement will be those elements outside of Q. And since Q is made up of the elements of that are in regions 2 and 3, the complement of Q would be those elements that are in regions 1 and 4. Now you notice we have a row for P, and we have a row for the complement of Q. So now we take the union of those regions, unite them, and we have what, 1, 2, 4? So all those elements that would fall in regions 1, 2, and 4 would be in the union of P and the complement of Q. So we circle that. That's like our answer row. We'll double circle it just to make it stand out over the other ones. Now, if we do the other set statement in the other table, and it's comprised of the same regions, then we say that those two set statements will always be equal. So again, we label the columns set and corresponding regions. We'll take a little bit of shortcut here because we have some work in our other table. We already have P, so let's take the complement of P. So since P is made up of the elements in regions 1 and 2, the complement of P would be those elements in regions 3 and 4. And then Q, we'll write down again. We've already done it, but Q is made up of the elements that are in regions 2 and 3. Now, if you look at that set statement number 2 over here, we have to do what's in parentheses first before we take that complement on the outside. So we have to intersect the complement of P and Q. Intersect means what they have in common. So 3 and 4 and 2 and 3, I guess they only have the elements that fall in region 3 in common, because those are the elements that are outside of P and at the same time inside of Q. So since it's P prime, or the complement of P, that means it's outside of P. Intersection means and. Q means inside of Q. So we want the elements that are both outside of P and inside of Q, which would just be those in region 3 in the Venn diagram. These elements here are outside of P, yet still inside of Q. And then lastly, on the outside of that parentheses was the complement. So we have to take the complement of what we just had. So we had region 3, so the complement of that would be all the regions outside of 3, or that are not 3, which would be 1, 2, and 4. So if you look at our two answer rows for each set statement, you notice each one represents those elements that are in regions 1, 2, and 4. So since they represent the exact same regions, they will always be equal set statements. So the answer is yes, they are equal. And then this work supports that answer.